welcome to everyone. Today we are going to discussing about another topic on computer network, which is transmission control protocol. So what is meant by this transmission control protocol? In the previously we were discussing about this TCP/IP reference model. So they are discussing about this 4 to 5 layers presence in the TCP/IP model only. So but same way in the previous session we were discussing about this user diagram protocol with IP. So similarly here we focusing about the transmission control protocol. In the previous discussing about UDP, what kind of services they offer, what kind of header format we have, that one. All these things we discussed in the previous session. Same manner. So in the TCP control, what is meant by this transmission control protocol, we discuss in this session. So what is meant by this transmission control protocol? So the TCP, which means the transmission control protocol. So this protocol has that we having as a facilities to transmission of packet from source to destination. We having as a limited kind of information, we have that one, we have to share the information from source to destination. So that kind of protocol we calling as a transmission control protocol, and this is a connection oriented protocol. So while see this UDP, that is the user diagram protocol, that is a connectionless protocol, but while coming to this TCP, this is a connection oriented protocol. This means we have to maintain the proper communication between the source and destination, then only we can able to share the information from source to destination. So because of that one, the TCP having as a high reliable services offer that one. And we having as a one main function of this TCP, it has to take the data from the application layer, then it divides data into several packets and provide the numbering to this packet, finally transmit this packet to the destination. So same way we go for the previous manner, we go for the segmentation, we go for the fragmentation mechanism. We have segmentation the information to n number of packets, and we have to transfer packets into the destination. And this TCP's other side, it will be reassemble the packets, which means send and receive the packet, send and transfer the packets to the application layer. And TCP is a connection oriented protocol, which means connection will remain establishment until connection is not completed between the sender and receiver. So here we're trying to achieve the information, maintain the reliable services. Once information is transmitted from source to destination, until the information is transmitted, information is completed, then only we can able to share the information only. Till we can't able to discard that one. And so here, what are the features of this TCP protocol? So the features of TCP protocol we calling as a transport control protocol. So this we calling as a we are maintaining the name itself is, we have that one, a transport layer protocol. So what is the information with transmission, that one we have to grab that one, and we go for this a transmission kind of a connection oriented mechanism, we process that one. So if it is a connection oriented communication, we can able to say high amount of accuracy is there, so we calling as a reliable services we offer that one. And similarly we having as a order of the data is maintained. So we have to maintain the sequence of information maintained with help of this information, because the information is transmitted in the continuous manner. In the connection oriented communication, continuous manner information is transmitted. So what are the packet we transmitted in the sequence manually we transmitted as well as we received. So order of the data is maintained, and as we know, this is a connection oriented communication. So this we get in the full duplex communication only. We send the information and we receive the acknowledgement. We go for this full duplex kind of communication also feasible here. And this should be a stream oriented services. And what is the need of this transport control protocol? So transport control protocol, the purpose of this protocol is when go for this host A, which means end-to-end communications established between host A and host B. Here we see this one. In the transport layer, we are involving about the structure of transport layer control protocol. We having as UDP is there, we having as TCP is there, and we having as SCTP also available, which means the transport layer takes data from the upper layer and information to the lower layer, from the network layer and to the application layer. So your data is during the smaller kind of packets based upon the fragmentation mechanism. These kind of packets we have that one. So that packets is smaller parts and transmit to the entire network layer, down the layers only. So that is a needed of this transport layer. And but what is the service model? We have that one. So the transport service model, what are the endpoints we achieve that one, that we calling as a socket. So this socket, every socket having a socket number which contains the respective IP address of the host and 16-bit port number. Every socket having as a host address value with 16-bit port address value. And this TCP services to be obtained in the connection, there must be establishment between the socket on one machine and socket onto the another machine. So this socket can be handle multiple connections at a time. This socket can be handled at a multiple connections at a time. So these TCP connections are full duplex connections and point-to-point connection. So this TCP does not support the multicasting or broadcasting. These TCPs does not support the multicasting or broadcasting services. And this TCP is a byte stream, not a message stream. What information we transmit that one, that should be the form of this byte stream, not a message stream. So these message boundaries are not preserved to end. So this process is the information is transmitted in the form of stream manner. There should be 512 bytes information. The chunks can information transmit that one. So that to be 512 bytes or 1024 bytes chunk, which we are having as a 4 times or 512 or 8 times of 254 kind of chunks we offer that one. And what is with this socket? So every socket, previously discussed about this primitive mechanism. Similarly, this we are having as a socket mechanism. A socket may be used for multiple connections at the same time, which means it indicates a 2 or more connections at may terminate the same socket. Because here the socket in a sense, we have to go for the connection of new communication request, create the new request at the endpoint. Next one is indication, the local address to be indicated. Next we listen the value. If it is in the busy state, you go for the queue size, or else in the ideal condition, accept the communication, connection is establishment. One connection establishment, then information is transmitted, then send the information. After information, the receive information is there. After successful information received, we release the connection. This is similar to the service primitives only. We calling a socket kind of structure. And what are the ports we offer that one? So in the port we having as a 256 ports. We are well-known ports and that should be reserved for the standard service only. We having as a port 1 to port 23 should be well-established connection, host, transfer the file transfer mechanism as well as the telnet mechanism. And we'll see this one. This is the TCP segment address. So here in the header file, we having a source port address. Similarly, we having as a destination port address. We having a sequence of 32-bit number, the sequence number as well as acknowledgement number. And here we having as header length value and result bit value. Apart from this one, we having a separate registers are there. URG, urgent registers, acknowledgement register, push register, reset register, synchronous and FIN register. These are the different kind of registers we are offering in the TCP segment address and respect to maintain the window size. And we having a checksum mechanism of 16 bytes and urgent pointer we having as a 16 bytes. And for a future perspective, options are padding we having as a 32-bit information. We have that one. And how the connection is establishment. So in the TCP connection establishment, in the host 1 and host 2 we have that one. In the host 1 we have to synchronize the connection. After successfully information connection is establishment, we send the information. After this is the information, we get the acknowledgement, then release the connection. So that we calling as a successful connection establishment in the normal case. But in the sample case, connection that established in both the scenarios, connection is establishment, connection is received synchronous manner. Similarly here synchronous manner should be happens to a simultaneous connection establishment of both the scenarios. And here the connection release mechanism is there. We have as initiator and we have as a receiver. So we have as establishment connection is there, and here also we having as a established connection is there. So here we having as a FIN communication, active close in first wait 1. Similarly there should be closed wait and we get the first acknowledgement. Next wait some more time, we get the FIN mechanism. Again we get the acknowledgement. After we get the acknowledgement, the connections are closed. So here we calling as a final state machine, which calling as TCP. Previously discussing about this UDP, same way we having as a TCP connection management mechanism. So we having as a closed state. If the closing sense first thing is listen state, if this should be synchronized send information, active send information. Similarly the received information. So once the connection establishment, the synchronous of positive acknowledgement as well as received information is there. If not, we get in the negative acknowledgement. If this successful establishment, we go for closed value or else the find connection. So then we go for the closed wait value, which we calling as the last acknowledgement, or else we go for the find state value, which means we have to wait for the value. After successful timeout, we close the connection. So what is transmission policy? So in the transmission policy, here one sender is there, one receiver is there. Here the applications are write the information and we having as empty state, we have that one. So here the sequence manner is there and we having as a window sequence of manner is there. So information is transferred from source to destination. So based upon the sequence structure, the full duplex communication, the application reads the value, we get the acknowledgement values only. So acknowledgement of 4096 window mechanism, and this having as the how many information we transmit, how many information block that one, how many information we write, how many information we send that one. All these things we follow the sequence manner that we calling as a transmission control transmission policy. And we calling as a silly window syndrome. Here we see this one. Here header length is there, and we having is 1 byte is information, and we having as a new byte arrives, which we having as a window update segmentation is there, which we calling as a room for one or more information. We have that one, and we having similarly we have receiver buffer full is there, and similarly if the receiver buffer full is there, the loop enter is going on occur. And this we calling as a TCP congestion control mechanism. The previous session we discussing about a leaky bucket mechanism, a token bucket mechanism, same way. So here we having as a fast network feeding mechanism with low capacity receiver. Here also we having a slow network feeding mechanism with high capacity receiver. We'll see this one. So transmission rate adjustment here, network transmission network policy adjustment. When we having a slower capacity receiver is there. So but faster sender is there. We have to adjustment the section values only. Here also a slow network is there, but faster receiver is there. We have to adjustment the internal congestion policies only. So one is small capacity receiver, other is large capacity receiver, but we have to control the policies here that we calling as the TCP congestion control policies. And what is the timer management? We having as a retransmission, we having a persistence, a keep alive as well as time wait. So if any mismatch occur, any data drawback should be happens, any losses should be happens, we go for the retransmission one, and we have to maintain the persistence of value, and we have to maintain the keep alive my connection value. After maybe time wait, we have to lose the connections. And what is with this retransmission timer? So if any loss segments are there, we initiate the retransmission policies. We have to use the retransmission timeout, we calling as RTO. If the segments are, the TCP send the segment to timer start value, start and stop when and the acknowledgement received. So if the timer expires after timeout occurs, the segments are retransmitted. So this RTO, the timeout mechanism, is for one RTT. To calculate the retransmission timeout, we first need calculate the RTT values only. And so based upon the analysis, we have to update the values. How we update the values of RTT? Alpha into RTT, which is 1 minus alpha into U. What is alpha here? My smoothing factor value, which means how much amount of weight is given to the old value. Most of the typically we are using this 1 by 8 values only. And the retransmission timeout, which is D is equal to alpha D into 1 minus alpha into my RTT value, where D is a smooth variable value and RT we calling as expect acknowledgement value, and where M we calling as the observe acknowledgement values only. And based upon timeout, we are go for this 4 into X into D. And persistence timer. What is persistent timer? Which we calling as zero window size deadlock situation. So we having as a limited kind of persistence timer we have the term. So that deals with the zero window timer. So this zero window timer, which means we are sending the information to TCP receiver. So we get the acknowledgement with window size of 0 value. It starts a persistent timer values only. But when persistent timer is off situation, when it goes to be off mode, so it send the packet to TCP mechanism and the special segment calling as a probe mechanism. So this consists of only 1 byte of new data. It has a sequence number, but its sequence number has never acknowledged. So it should be simply ignore the calculating the values. But this probe caused the receiving TCP resend the acknowledgement which was lost. And keep alive timer, which means a connection should be, the timer should be present a long L connection between the two transmission control protocol, two TCPs. So which the client should be open communication to serve the transfer. Some data becomes a silent and client we will crash the information. So here what happened, the timer should be usually rush in the 2 hours. So here should be we want to maintain the alive manner only. And time wait timer. So it has to start the wait time manner after sending the post acknowledgement every FIN segment. So we have to receive the final acknowledgement if it is information is lost. So the value of time maintain the usually twice of the lifetime of transmission control protocol timer. So in this session we have to maintain the what is the transmission control protocol and how we are able to manage situations based upon the different scenarios. We grab that one, how we are able to manage that one while using this based upon the retransmission policies or the window policy. All these things we discuss in this session. Thank you.